Today we are talking about hyperbolas. Hyperbolas are formed, they are one of our conic sections, and they are formed from a double cone. So consider this double cone, okay? Alright, if a plane intersects both of these cones, it doesn't have to be completely perpendicular to the floor or to the ground. Any kind of a slanted plane, if it intersected this, it would form, where it intersects, it would form this hyperbola. I don't know if you can envision that, but that's how a hyperbola is formed. They look like two parabolas, but they are not. They are not parabolas. Hyperbolas have linear asymptotes. These two legs, as they go on, they get closer and closer and closer to these lines. So as it goes on, it's going to look like, if I only showed you that part of it, you would swear it was a line. And it's not. It's part of the hyperbola. Hyperbolas are only curvy, like really noticeably curvy, for part of the graph, and then the rest of the graph, it looks like a line. It looks really like a line. Parabolas are not like that. If this was a parabola, it would be very curvy the whole way. You would really see the slant. You would really see the curve. Okay? So, hyperbolas. Hyperbolas have the same general form, except either the x's can be positive or the y's can be positive. On your notes, unfortunately, the copy of your notes this year, the year that I'm making this video, I cut and pasted and I didn't go back and fix it. So you'll need to update this equation over here. Change that to y minus k over a squared and change this to x minus h over b squared. Okay, so either the x's can be positive or the y's can be positive. That determines if you're going to be going in the x direction, like this one. This is where the x squareds are positive, or in the y direction. This is where the y's are positive. So if the x squareds are positive, these are your two vertices. If the y's are positive, then these are your two vertices. Your vertices are vertical if y is positive, horizontal if x is positive. Okay? Alrighty, we still have one on this side, just like ellipses. Okay? A squared and b squared can be the same or different. It doesn't matter. Okay? It makes it a hyperbola if you have one of the squared terms being negative. Okay? So let's begin by sketching a few of these hyperbolas. I think the plural of I don't know what it is. Okay. Anyway, the center here is at -1, 3. -1, 3 is the center. Okay, I'm still going to go 3 in the x direction. Okay, and I'm still going to go 5 in the y direction. If there was a plus here, I would connect these and it would be an ellipse. But there's a minus there, and that means that this is a hyperbola, and here's how you graph it. What we do with these points is we form a box, okay? This box definitely is not part of the curve, okay? It just helps us to graph the curve. So I'm going to lightly form a rectangle using these points as the center of each side of the rectangle. And then I'm going to get a straight edge. You can use your ID tag or a little ruler. Okay, and I'm going to draw a diagonal. These are going to be the asymptotes. They go through the center and each of the corners. So these are going to be the asymptotes of the hyperbola. the two diagonals. Okay, so now we're going to draw the actual curve. So now I find out which is positive. Which is positive? Well, the x's are positive, so these two are my vertices. I will not use the other y ones again. I've already used them to form the asymptote, and that's all I need those for. So then I start my curve, and as it approaches the asymptote, make sure that you approach the asymptote. It should look like it's lying right on top of the asymptote as we get closer. So this one, see how I really didn't, I got closer and closer, but I probably should have really gotten closer faster, because it gets close pretty darn fast. Okay, for this one. And this side. I did better on that one. Okay, that's the hyperbola. Notice how wide these arms are and how thin these arms are. Okay, that means that these two hyperbolas have different eccentricities. We'll be talking about that in a moment. Okay, let's graph this next one. So we have, where's your center? Be careful with your center, because the center is going to be -1 from the x's and then up 4 for the y's. So the center is -1, 4. -1, 4. That's the center. I go 4 units up and down from the center, and 6 units side to side. I use those to form my box. And now I use those to form my asymptotes. All right, and now I'm ready for the actual hyperbola. I look to see which is positive. In this one, the y's are positive. So I'm going to use the y vertices. The other two I will not use again. This hyperbola is in the vertical direction. Okay. Make sure that you do not draw. Make sure that you do not draw it. Let me get a different color here a little bit. Make sure that you, when you draw this, make sure you do not make it look like a parabola. Don't do that. It does not look like that. It needs to get closer and closer to those asymptotes. So it needs to really come out here like that. Okay. I would rather see it lying right on top of the asymptote than to be curving away from the asymptote. Okay, next one. So for the next one, I notice that these are the same. It doesn't matter. I see one positive, one negative, so I know I'm looking at a hyperbola. So I go to my center. This time the center is right at the origin. I'm going to go 3 units in the x direction, 3 units in the y direction, 3 units up, down, right, and left. And then I've used that to form my box. And then I use my box to form my asymptotes. if you did this right, your asymptote should be going through all four corners of this grid. Okay? All right, now we're going to sketch the actual curve. The x's are positive, so I use the x vertices. These are called the vertices. And I draw the curve. Okay? Just like that. They're very pretty things. All right. The vertices of the hyperbola are the points on the box that are on the graph. So these are the vertices. Okay? What are the vertices in 1A above? What are the vertices in 1A? That would be the point 2, 3, and -4, 3. Okay? I can look at the graph and get them, right? But what if I didn't have the graph to look at? If I didn't have the graph to look at, here's how I would do that. See the equation? I would get my center. The center is at -1, 3. And I would go plus and minus 3. Because of the 9 here, I would go plus and minus 3 from the x's to get the vertices. Plus and minus 3. That would give me 2, 3 for the plus 3 and -4, 3 for the minus 3. Okay? What about 1b above? So I can count, since I already graphed it, it's easy to get the vertices. -1, 8. -1, 8, and -1, 0. But what if I didn't have the graph to look at? Then I would go to the center, which is -1, 4, and since y is positive, I would add and subtract 4 from the y coordinate to get the vertices. And that would give me what I just wrote. Okay. Given this, what is the center? What is the center? Well, the center is 6, -9. Okay. What are the vertices? Well, the center is 6, -9. X's are positive, so from the x coordinate, I'm going to add and subtract 8, square root of 64. So that would give me 14, -9, and -2, -9. What about this one? The center is the point 0, 11. Be sure that you get your x coordinate for the center there. Okay, since y is positive, I'm going to add and subtract the square root of 81 from the 11. This will give me my two vertices, 0, 20, and 0, 2. Not too bad. Okay, next up for hyperbola are the foci. So the foci lie on the inner part of the curves. Okay, they do not lie like close to the center. They lie on the other side. So this is the center. That's the center. And here are the vertices. The foci lie on the other side of the two vertices. Okay. This distance from a focus to the center is still our little c. All right. And it's worthwhile to say that the difference of the lengths of the foci to a point on the parabola is a constant. The difference is. Okay? That's the definition of a hyperbola officially. To find the foci, you're going to find the value of this little c, that distance. To get little c, you use this equation. Okay? For a hyperbola, we have a minus there. To get little c, you do the opposite of it. You do the plus. Okay? For an ellipse, we have a plus here. To get little c, we put a minus there. So it's the other way around. Let's find the foci of this hyperbola with this equation. So I set up c squared is a squared plus b squared. So I just add these two. So 64 plus 36 is 100. So c, the distance from the center, remember that's the distance. From the center to a focus. Okay? So to get the two foci, I'm going to write the center. The center is the point -3, 1. X is positive, so I add and subtract little c from the x coordinate because x was positive. That's where my foci will lie. So the foci are, let's see, 7, 1 and -13, 1. Let's do the same thing again. Find the foci of this hyperbola. So I start off, c squared for a hyperbola is a squared plus b squared. I think to myself, if there's a minus here, to get little c, I add these two. So 9 plus 36 is 45. So c is the square root of 45, which if you prefer, you can write that as 3 square root of 5. Yeah, 9 times 5. Okay. So my center is the point -8, 5. And so to get the foci, I add and subtract 3 square root of 5 from the y coordinate of the center. Add and subtract 3 square root of 5. So my foci, will be the point -8, 5 plus and minus 3 square root of 5. If you prefer to write them as two distinct points, not all in one, that's fine. All right. You probably knew this was coming. What if we're given the equation in this form? Well, we're going to need to complete the square, just like we have been doing. Hopefully you've gotten very quick, and this is not a hard thing. We're going to group our x's together with a little space in between them and the y's. I put a plus out of habit, but this is a -4y squared minus 32y. Take your 64 to the other side. Okay. I need to factor a 9 out of the x's. Leave a space. I need to factor a -4 out of my y's. And be careful, you're factoring a -4 out. So this will be y squared plus 8y. Okay. Complete the square on your x's. Half of 4 squared is 4. 9 times 4 is 36, so we're really adding 36 to this side. So I need to add 36 to the other side. Okay. For our y's, I'm going to add half of 8 is 4, squared is 16, but I'm actually subtracting 64. So I need to subtract 64. -4 times 16 is -64. I need to do that on both sides. So this will give me 9 times x plus 2 squared when we factor, minus 4 times y plus 4 squared on my y's is equal to 36. We divide both sides by 36, and we get x plus 2 squared over 4 minus y plus 4 squared over 9 is equal to 1. Standard form. Okay, let's go graph it. The center is -2, -4. We're going to go 2 in the x direction, 3 in the y direction, form our box, draw your asymptotes, and now draw your curve. The x's are positive, so these are my vertices. And we draw our curve. And there's our hyperbola. Okay. Let's find the vertices and foci of the hyperbola with this equation. Okay, it's not in standard form, so I need to get it in standard form. -4x squared plus 16, leave a space, plus y squared minus 6y, leave a space, is equal to 11. Move that 11 over. Factor out a -4 from our x's. We're factoring out a negative, so this needs to be a minus 4x. We don't need to factor anything out of our y's. Alrighty. We're going to add 4 for our x's. But we really did what? We really subtracted 16 there. I'm going to add 9 for our y's. Like that. And then we get -4 x minus 2 squared plus y minus 3 squared is equal to 20 minus 16 is 4. Okay. I'm going to divide both sides by 4. When I do that, I'm going to have a negative x minus 2 squared over 1 plus y minus 3 squared over 4 is equal to 1. Alright, now I left my minus there. We could, if we wanted to, swap these and put the minus in the back, but I think I'm okay leaving it right there. Okay? Alright, the center is the point 2, 3. That's the center. We need the vertices and we need the foci. To get the vertices, which one is positive? This one is positive. So from the y coordinate, I add and subtract 2 for the vertices. So my vertices will be 2, 5, and 2, 1. Those are my vertices. For the foci, also from the y coordinate, for the foci, I add and subtract little c. I need to find out what little c is. I'm going to come over here. C squared is a squared plus b squared. We just add those two, and we get 1 plus 4, which is 5. So c is the square root of 5. So for the foci, we add and subtract square root of 5 from the y coordinate of our center, and the foci will be 2, 3 plus and minus square root 5. Okay, so that's the foci. All right. I kind of mentioned this when we did ellipses yesterday. But an interesting application of conic sections involves the orbits of comets in our system, our solar system. Of the 610 comets identified prior to 1970, 245 have elliptical orbits. 296 have parabolic orbits, and 70 have hyperbolic orbits. The center of the Sun is a focus of each of these orbits, and each orbit has a vertex at the point where the comet is closest to the Sun. For sure, there have been other comets with parabolic and hyperbolic orbits that were not identified because we only get to see those comets once. Comets with elliptical orbits, we see those every so often. They come around every time they go every time they go past the Earth in their orbit, right? But the ones with hyperbolic and parabolic orbits, we only see them once. Interesting, Alrighty, eccentricity. As with ellipses, the eccentricity of a hyperbola is still given by c over a. Since c is always bigger than a, because c is a squared plus b squared, right? So c is always bigger than a in a hyperbola. So e, the eccentricity, will be bigger than 1 for a hyperbola. When eccentricity is large, here eccentricity is a little over 5. When eccentricity is large, the branches get flatter and flatter and flatter. They get like more similar to parallel lines. They're not, but they are looking more along that. Okay. If the eccentricity is close to 1, then we get those skinny arms. Okay, this eccentricity is 1.019, so it's very close to 1 for this one. So large eccentricity, close to 1 eccentricity. Let's determine the eccentricity of the hyperbola with this equation. Okay, so I'm finding eccentricity. So I know how to do that. That is, eccentricity is c over a. Okay. So I need to find c. C squared is a squared plus b squared for a hyperbola. So I add these two up. I get c squared is 54. So c is the square root of 54, which is 3 square root of 6. Okay. A is always the square root of the positive piece. Okay, it's where your vertex is. Okay, it's where the two vertices are. So A is the square root of 24, which is 2 square root of 6. Okay, so eccentricity is 3 square root of 6 divided by 2 square root of 6, which is 3/2. Alrighty, let's do something else with hyperbolas. Okay, what if I gave you the graph of a hyperbola and I asked you to find the equation, eccentricity, foci, and asymptote equations? All right. Well, it's a little bit harder, and we have to go with a couple of assumptions here. My assumptions are that that my box is going to lie right on a whole number or an integer point. Okay, that is my assumption here. My vertices appear to be right here. Those are my vertices, okay, which makes my center right here. Okay, I find it easiest to draw my asymptotes right now. I'm going to lie my straight edge so that I connect the furthest point out here with the furthest point down here. Okay? I'm lying it so that it connects, or I think it's going to connect, and go through the center. That is key. I need to go through the center. Okay? Something like that. And then I'm going to do the same thing over here. I'm going to connect my center with the outside of my hyperbola legs. Okay? Just like that. All right. I know where my two vertices are. That means that where that meets the asymptote about, that's going to be the corner of my box. Okay? This is the corner of my box. So here's my box. All right? That means that this is A, and this is B. So from that, I can get all of my equation. Get all of my equation. So which is positive, the x's or the y's? Well, the x's are positive because that's where my two legs are. So x minus the x coordinate of my center, the x coordinate of my center is 2. So x minus 2 squared over a squared. A is 3, so I'll be over 9, right? Minus, here come my y's. Y, and I'm down 2, right? So y plus 2 squared for the y coordinate of my center, and b is 4, so underneath here I need 16. There's my equation. And now I can get everything else that they asked me for. So for eccentricity and the foci, I'm going to need little c. So c squared is 9 plus 16. 9 plus 16 is 25, so c is 5. Okay. My center is 2, negative 2. So to get my foci, I will add and subtract 5 from my center, from my x coordinate of my center. Add and subtract 5. So my foci are 7, negative 2, and negative 3, negative 2. Let's plot those points. 7, negative 2, 7, negative 2, and negative 3, negative 2. Those are the foci right there. Okay? We need eccentricity. Eccentricity, E, is c over a. So 5 over a is 3. Eccentricity is 5/3. Okay? Now we need the asymptote equations. Well, the two asymptotes are lines, right? They are lines. And if they're lines, to write the equation of a line, I need a point and a slope. Point and slope. Okay? A very convenient point is the center, because both go through the center. So I'm going to use the center for both of mine. The center is 2, negative 2. The slope. How do you get the slope? The slope of this line is up 4 over 3 or down 4 over 3. The slope is positive and negative 4 over 3. Notice that that is the square root of the y coordinate divided by the square root of the x, not coordinate, but what's underneath the x's. Okay? it will be that all the time. So if I want the equation, and I do, it'll be y minus the y, I'm going to write this out for sake of your notes. Y minus the y coordinate of your point is equal to the slope, I'm going to write this as just one equation, times x minus the x coordinate of your point. Okay? This is fine to leave this. This is an equation of the asymptotes. So these are the things that they asked me for. Now there we go. We got it. Okay, let's do one more like that. Here's the graph, and we want to find all of that stuff. So I find my vertices so that I can find my center. And now I'm going to connect my center with the end of each of these long arms, right? Like that. Oops. Okay. And from that, I try to get that box. So if I go from my vertex there to the line, I should be at the corner of my box, right? And then do it on this side. I'm assuming that these come through, and the way I made them, they hit right on a whole point there. Okay. All right. So what is little a? What is little b? Well, little a is 2, and little b this time is 1, 2, 3, 4, 5. Okay. So my equation will be, this time my equation has the y's positive. So y squared minus x squared. Okay. The center is the point 1, 2, 3, negative 4 on the x, in the x direction, and then in the y direction 1, 2, 3, 4. Up 4, so minus 4 for the y's. Okay. The 2 is in the y direction. The 5 is in the x direction. Equals 1 to finish my equation. If they ask for the equation, you have to have that equals 1. All right. Once again, I'm going to get little c. For little c, I add 4 plus 25 for a hyperbola. That's 29, so c is plus, and well, just square root 29. So to get the eccentricity, I take c over a. So c is the square root of 29. A is the square root of 4, 2. The foci. For the foci, well, the center is negative 4, positive 4. And the foci lie in the y direction, so we change y, add and subtract c, square root of 29. So the foci are negative 4, 4 plus and minus square root 29. Now for the equation of the asymptotes. Point, slope. The point, I'm going to use the center as the point. That was negative 4, 4. For the slope, I went up 2 over 5, or down 2 over 5, 2/5. So the equation will be y minus the y coordinate is equal to the slope times x minus the x coordinate. That's the equation of the two asymptotes. And that is it for hyperbolas. A little bit of a longer lesson today.